Welcome, and let the room grow soft and still around you. As your breathing slows, all on its own, imagine stepping outside into a cool and quiet night and turning your face toward the southern sky, where a bright pair of stars hangs low above the horizon, and there, hidden beside them, far too faint for any eye to catch, burns a small red ember of a star. It is the nearest star to our sun, closer than any other in all the sky, and still so far away that light itself needs more than 4 years to cross the gap. Its name is Proxima Centauri. Tonight we will drift toward it together, one gentle fact at a time. There is nothing at all you need to hold on to now. Just breathe and let go, and welcome back to Beyond the Stars. The first fact is that Proxima Centauri is the closest star to our sun, the nearest neighbor we have in all the enormous dark. Of the hundreds of billions of suns that fill the Milky Way, this one small red star sits closer to us than any other, and it has held that quiet distinction for tens of thousands of years. Its name comes from the Latin word for nearest, and it was chosen for exactly that reason, plainly and honestly. It is not the brightest star, nor the largest, nor in any way the most dramatic. It is simply the one next door, a small, patient light burning steadily at the edge of our own neighborhood, closer to you tonight than any star but one. The second fact is that Proxima Centauri lies about 4¼ light years away from us, a distance astronomers write as 4.24 light years, which means that the light falling on our telescopes tonight left that little star more than 4 years ago, when the world was a somewhat different place and you were a somewhat different person. Nothing we can ever see of it is truly current. We are always looking at a small piece of its past, gently delayed, arriving late. And yet, of all the stars in all the sky, this is the freshest news the universe has to offer us. The shortest delay, the nearest voice, the closest thing to a neighbor speaking now. The third fact is that even though Proxima Centauri is the nearest star of them all, you cannot see it with your eyes. Not from the darkest desert, not from the highest mountain, not on the clearest night that has ever been. It shines at about the 11th magnitude, which places it roughly 100 times too faint for unaided human sight. You would need a good telescope simply to pick it out of the crowded background of the southern Milky Way. There is something quietly humbling in that thought. The very nearest of all the stars is invisible to us, hiding in plain sight, in a patch of sky that looks, to the naked eye, entirely empty. The fourth fact is that Proxima Centauri lies in the direction of the constellation Centaurus, the centaur, a great sprawling figure of the southern sky. Centaurus is one of the largest constellations in the heavens, and among its brightest ornaments is the pair of stars known as Alpha Centauri, which many people call Rigil Centaurus, the foot of the centaur. Proxima sits just beside that bright pair, a little more than 2 degrees away from them on the sky, about 4 times the width of the full moon. To find it, you must know exactly where to look, and you must bring glass with you. But it is there, always, tucked quietly beside its brilliant companions. The fifth fact is that observers in the northern half of the world can rarely see this part of the sky at all. Proxima Centauri and its bright companions sit far down in the southern celestial hemisphere, which means that from most of Europe, from Canada, from Japan, and from nearly all of the United States, they never rise above the horizon at any hour of any night. To see the nearest star system to our own, you must travel south, toward Australia or Chile or southern Africa or the tropics. Half of humanity has never laid eyes on our closest stellar neighbors, an ordinary fact of geometry that carries an unexpected touch of wonder in it. The sixth fact is that Proxima Centauri is what astronomers call a red dwarf, which is the smallest and coolest and most modest kind of true star there is. It carries only about 12% of the mass of our sun, and its width is roughly 14% of the sun's width, which makes it not very much larger than the planet Jupiter. If you set the two side by side, our Sun would look like a great golden lantern and Proxima like a single glowing coal beside it. And yet it is a real star, fusing hydrogen quietly in its core, holding planets in orbit around it, shining faithfully, small, but entirely genuine. The seventh fact is that the surface of Proxima Centauri is only about 3000 Kelvin, which by the standards of stars is remarkably cool. Our own Sun runs at nearly 6000 Kelvin at its visible surface, twice as hot, and it burns with a white-yellow light. Proxima, being cooler, glows a deep and gentle red-orange, the color of an ember settling in a fire late at night, or of iron just beginning to lose its heat. If you could somehow stand at a safe distance and look at it directly, it would not dazzle you at all. It would simply glow, quietly, warmly, like something already halfway to rest. The eighth fact is that Proxima Centauri is astonishingly faint, radiating less than 2/1000ths of the light our Sun pours out. In visible light alone, the difference is even more extreme, for most of what Proxima emits comes out as infrared, as gentle heat rather than as anything our eyes could register. If our Sun were suddenly replaced by Proxima Centauri, the daytime sky would fall to a deep and permanent dusk, and the oceans would freeze solid. It is a small flame in a very large room, and yet it is enough at close range to warm a world, which is a thought we will return to before the night is over. The ninth fact is that astronomers classify Proxima Centauri as a star of spectral type M, the very last and coolest letter in the great sequence of stellar classes. The old ordering runs from the blazing blue O stars down through B, A, F, G, K, and finally M, and our own Sun sits comfortably in the middle at type G. The M stars are the smallest members of the family, the dim red ones, and Proxima is given the more precise designation of M5.5. It sits fairly deep into that class, well down toward the cold end, a small red ember near the bottom of the ladder of stars. The 10th fact is that stars like Proxima Centauri are by far the most common kind of star in the entire galaxy, which is a fact that surprises almost everyone who hears it. Something like 3/4 of all the stars in the Milky Way are red dwarfs, small and dim and long-lived. The bright ones we name and admire and build constellations from are the rare exceptions, the loud minority. The typical star is not a brilliant beacon at all, but a quiet red coal too faint to see. So Proxima is not an oddity. It is, in truth, the most ordinary sort of star there is, and we simply happen to live beside a brighter one. The 11th fact is that Proxima Centauri holds a special place in the language of astronomy, because the phrase nearest star can mean two rather different things. To an astronomer, the nearest star to the Earth is really our own Sun, which sits a mere 8 light minutes away and warms your face on a summer afternoon. Proxima is the nearest star other than the Sun, the nearest of the night stars, the closest of the distant ones. Both statements are true, and the difference between them is the difference between 8 minutes and 4 years of light. That gap in a single sentence is the whole shape of our solitude, and the whole shape of tonight's journey. The 12th fact is that the position of Proxima Centauri as our nearest neighbor is not permanent, for the stars are all in motion and the neighborhood slowly rearranges itself. Proxima is drifting gradually closer to us at the moment, and in something like 26,000 years it will make its nearest approach, coming within roughly 3 light years of the Sun. After that, it will begin to recede again, and in the far future some other star will take the title. Nothing in the sky is fixed, only slow. The nearest star tonight will not be the nearest star forever, but it will hold the title for longer than any human story we know. The 13th fact is that Proxima Centauri moves across our sky faster than almost any other star, which is one of the ways it first drew attention to itself. Astronomers call this proper motion, the slow apparent creep of a star against the far more distant background, and Proxima shifts by nearly 4 seconds of arc every year. That sounds like nothing at all, and it is nothing at all to the eye, but on a photographic plate it is unmistakable. Over a single human lifetime, it would drift by a distance you could measure with confidence. Nearby things appear to move quickly, and that simple truth is exactly how the star was noticed. The 14th fact is that Proxima Centauri is bound to 2 other stars, and together the 3 of them make the closest star system to our own. The 2 others are called Alpha Centauri A and Alpha Centauri B, a bright and handsome pair that circle one another closely, and to the unaided eye they merge into a single brilliant point low in the southern sky. Proxima orbits far outside them, a distant and lonely 3rd member of the family. So the nearest star to us is not a solitary wanderer at all. It has company, though its companions lie so far off that they would look to it like nothing more than 2 very bright stars. The 15th fact is that the bright pair, Alpha Centauri A and B, lie about 4.37 light-years from us, slightly farther away than Proxima itself. Proxima happens to sit on the near side of the system just now, which is part of why it holds the crown. The difference is a little more than 1/10 of a light-year, roughly 1,000 billion kilometers, which is a trifling gap by the standards of the stars and an unthinkable one by any other measure. 3 stars, then, bound loosely together, all of them close to us as such things go. A small, quiet family holding the nearest patch of sky to our own. The 16th fact is that Alpha Centauri A is remarkably like our own sun, close enough in size and color and temperature that it might almost be its twin. It is a yellow star of type G, slightly larger and slightly brighter than the sun, and if our sun were placed beside it you would struggle to tell them apart at a glance. Its companion, Alpha Centauri B, is a somewhat smaller orange star, cooler and dimmer. And then, far out beyond them both, drifts Proxima, the small red ember. 3 stars, 3 different colors, 3 different sizes. An entire small catalog of stellar variety gathered into the nearest system we have. The 17th fact is that seen from the Earth, Alpha Centauri appears as the 3rd brightest star in the whole night sky. Outshone only by Sirius and by Canopus, it blazes low in the south for those who live far enough down the globe to see it. A warm yellow point of light that has guided navigators and been named in a dozen languages. Almost no one looking at it realizes that they are seeing 2 stars merged into one by distance, or that a 3rd, invisible one drifts nearby. The brightest things in the sky rarely tell the whole story, and the most interesting member of that family is the one you cannot see. The 18th fact is that the Proxima Centauri system sits inside what astronomers call the local bubble, a great cavity in the interstellar medium carved out long ago by exploding stars. This bubble is a region of unusually thin, hot gas, hundreds of light-years across, and our sun happens to be drifting through the middle of it. Within that thin region, the space between stars is emptier than usual, cleaner, more transparent. It is one small reason our view of the nearby stars is so clear. We and our nearest neighbors share the same quiet hollow in the galaxy. A calm and rather empty room, hollowed out by violence we never saw. The 19th fact is that Proxima Centauri, being so near, has become one of the most watched and studied stars in the whole sky. Telescopes on mountaintops in Chile follow it night after night. Space observatories measure its position to extraordinary precision. Radio dishes have listened to it. Instruments have traced the tiny wobble in its motion, the flicker of its brightness, the shape of its light broken apart into colors. For a star that no human eye has ever directly seen, it has been examined with remarkable devotion, simply and entirely because it is close, and because closeness is the rarest and most precious thing in astronomy. The 20th fact is that there is something quietly comforting in knowing that our nearest neighbor is a small, dim, patient star rather than a raging blue giant. Proxima will still be burning long after our sun has swelled and faded and gone. It asks nothing of us. It has no bearing at all upon our lives, and it never will. It simply glows there, 4¼ light years away, keeping its own small fire in the dark. As you settle deeper into the night, you might hold that picture gently in mind. One little red star, unseen, unhurried, burning quietly at the near edge of the enormous dark. The 21st fact is that Proxima Centauri was discovered in 1915 by a Scottish-born astronomer named Robert Innes. Working at the Union Observatory in Johannesburg, in South Africa, he was not searching for the nearest star in the universe. He was patiently comparing photographic plates of the southern sky, looking for stars that shifted their positions from year to year. And there, close beside the brilliant pair of Alpha Centauri, he found a faint red point of light that was creeping along at very nearly the same rate and in very nearly the same direction. It was a small mark on a glass plate, and it turned out to be our closest neighbor in all the galaxy. The 22nd fact is that Robert Innes gave the little star the name Proxima Centauri himself, choosing the Latin word for nearest even before anyone had proven that it truly was. He suspected it, from the way it moved and from its apparent faintness, but suspicion is not measurement. It took several more years and careful work by other astronomers before the distance was pinned down well enough to confirm what he had guessed. The name was a small act of confidence in the dark. He was right as it happened, and the name has stayed ever since, through every catalog and every revision. There is something rather touching in a man naming a thing for its nearness years before anyone could prove that it was near. A Latin word for nearness, given to the nearest thing there is. The 23rd fact is that Johannesburg in 1915 was an unlikely place for one of the great discoveries of astronomy. And that is part of what makes the story lovely. Innes had begun his career as a wine merchant in Australia, an amateur observer who taught himself the sky in his spare hours, and who was eventually invited to South Africa on the strength of his careful work with double stars. He had no formal training in astronomy whatever. The nearest star to the sun was found by a self-taught man with a good eye and enormous patience, which is very often how these things happen. The 24th fact is that the discovery depended entirely on a technique called blink comparison, a beautifully simple idea for finding things that move. You photograph the same patch of sky twice, months or years apart, and then flip rapidly back and forth between the two images. Everything that has stayed still stays still, and anything that has shifted appears to jump. It was the same method that would later reveal the planet Pluto. In a field of thousands of motionless points, the one that hops is the one that is close. Proxima hopped, and by hopping it announced itself. The 25th fact is that the reason a nearby star appears to move so much is a matter of simple perspective, the same effect you can see from the window of a moving train. The fence posts beside the track fly past, the trees in the middle distance drift more slowly, and the mountains on the horizon barely stir at all. The sky works precisely the same way. Distant stars are the mountains effectively fixed. A close star is a fence post. Proxima Centauri is one of the nearest fence posts we have, and so it slides along more visibly than nearly anything else. Motion in astronomy is very often just another word for closeness, and a star that hurries across the sky is nearly always a star nearby, which is exactly how Innes caught it. The 26th fact is that Proxima Centauri is bound by gravity to Alpha Centauri A and B, which means that all three stars form a single system held together across an enormous gulf. For many years, this was uncertain. The three stars share a motion through space, drifting together in the same direction at the same speed, which strongly suggested a real connection. But sharing a direction is not the same as sharing an orbit. It took a century of increasingly precise measurement to settle the matter properly, and only recently has the answer been confirmed. Yes, they belong together, though only just barely. The 27th fact is that Proxima Centauri orbits the bright central pair at a distance of about 13,000 astronomical units. An astronomical unit is the distance from the Earth to the Sun, so this is 13,000 times the width of our own orbit, which comes to something like 1/5 of a light year. That is an extraordinary distance for two things to be bound together by gravity. It is more than 400 times the distance from the Sun out to Neptune. The bond that holds them is almost impossibly gentle, a thread of gravity stretched thin across the dark. And yet it holds. The 28th fact is that one full orbit of Proxima Centauri around the central pair takes something like 550,000 years, which is a span of time so long that it can barely be called an orbit in any ordinary sense. When Proxima last occupied the position it occupies tonight, our own ancestors had not yet learned to make fire reliably. It has not completed even 10,000 circuits in the entire lifetime of the star. This is patience on a scale nothing on Earth has ever matched. No civilization has lasted long enough to watch even a single degree of that circle be completed, and none ever will. One slow, silent lap taking longer than the whole history of our species several times over. The 29th fact is that because the orbit is so vast and so slow, we have never seen Proxima Centauri complete any meaningful fraction of it. In the century since its discovery, it has traveled through less than 1/50th of 1% of its path. Everything we know about that orbit comes not from watching it happen but from measuring the star's speed and direction with extreme precision and then working out mathematically what shape of path could produce it. It is astronomy done by inference rather than by observation, which is much of what astronomy is, reading a whole circle from the faintest hint of a curve. The 30th fact is that for a long time astronomers genuinely wondered whether Proxima was bound to Alpha Centauri at all, or whether it was merely passing by in the same direction by coincidence. The question was settled in 2016 and afterward, using measurements of the star's velocity so precise that they could detect motions of a few meters per second. The answer showed that Proxima is moving just slowly enough, relative to the central pair, to remain gravitationally captured. It is bound, but only just, and a slightly faster nudge in the distant past would have set it free forever. The 31st fact is that seen from Proxima Centauri, the bright pair of Alpha Centauri A and B would not look like a sun at all, but like two extraordinarily brilliant stars close together in the night. They would shine with a combined brightness many times greater than the full moon appears to us, bright enough to cast sharp shadows on the ground, bright enough to read by. But they would still be points of light, not disks. Any world orbiting Proxima would have a night sky graced by two dazzling lanterns, near enough to dominate the dark, and far too distant to bring any warmth. The 32nd fact is that the Alpha Centauri system, taken as a whole, is one of the most closely examined objects in all of astronomy, and it has been so for nearly 2 centuries. Its distance was among the very first stellar distances ever measured, worked out in the 1830s by the Scottish astronomer Thomas Henderson from the Cape of Good Hope. He was, in fact, the first person in history to measure the distance to any star beyond the Sun, though he was slow to publish and lost the credit. The nearest system taught us how to measure the sky, and then quietly let someone else take the honors. The 33rd fact is that Robert Innes spent much of his career cataloging double stars, patiently recording pairs of suns that circle one another in the southern sky. He published thousands of them, an enormous and unglamorous labor of measurement carried out night after night in the clear air above Johannesburg. Proxima Centauri was, in a sense, a byproduct of that steady work, a small anomaly noticed by a man who had trained his attention on exactly this kind of detail. Great discoveries very rarely arrive as bolts from the blue. Far more often they are found by someone already looking carefully at something nearby. The 34th fact is that the star has carried several names in the centuries since its discovery, and the older catalog designations still appear in the scientific literature. It is known as V645 Centauri in the catalogs of variable stars, because its brightness changes, and it appears under several other numbers in various surveys. But the name Innes gave it has never been displaced because it is simply 2 apartment Proxima, the nearest. No catalog number has ever competed with a name that describes the thing so exactly. Names endure when they are true, and this one has been true for more than 100 years and will remain true for tens of thousands more. And so the Latin word has outlived every alternative. The 35th fact is that the modern distance to Proxima Centauri is known with astonishing precision, thanks to spacecraft designed to do nothing but measure stellar positions. The European mission called Hipparcos began the work, and its successor, Gaia, has refined it to a level that would have seemed like fantasy a generation ago. Gaia measures the tiny annual wobble of a star's position caused by the Earth's own motion around the Sun, and from that wobble the distance falls out directly. We know how far away our nearest neighbor is to within a fraction of a percent, a number measured, not estimated. The 36th fact is that the wobble used to measure the distance is called parallax, and it is the same effect you can demonstrate right now by holding up one finger and closing each eye in turn. The finger appears to jump against the far wall. The closer the finger, the bigger the jump. For stars, our 2 eyes are the Earth's position in January and its position in July, 300 million kilometers apart. And even across that enormous baseline, the jump for Proxima is less than 1 second of arc, which is roughly the width of a coin seen from several kilometers away. The 37th fact is that the 3 stars of the Alpha Centauri system very likely formed together, out of the same collapsing cloud of gas and dust several billion years ago. They share a common age and a similar chemical composition, which is the strongest evidence for a common birth. Stars are almost never born alone. They form in clusters in great nurseries of cold gas, and most such clusters slowly dissolve as their members drift apart. These 3 have stayed loosely together through billions of years of galactic wandering, through countless slow passages near other stars, never once pulled fully apart. That is a remarkable feat of endurance for a bond as thin as the one holding Proxima in place. Siblings who have never quite separated, still traveling side by side through the dark. The 38th fact is that the Alpha Centauri system is probably somewhat older than our own sun, perhaps 5 or 6 billion years old against our sun's 4.5. The estimate comes from studying the chemistry and the rotation of the 2 bright stars, both of which change in predictable ways as a star ages. If that is right, then Proxima Centauri was already shining before the Earth existed, before the Sun had condensed out of its own cloud. It was old when our world was new, and it will still be young when our world is long gone. The 39th fact is that the whole system is drifting through the galaxy on its own long orbit around the distant galactic center, exactly as our Sun is, and the 2 paths happen to run close together at present. Over the coming tens of thousands of years, Alpha Centauri and its little red companion will approach us, reach their closest point, and then begin to draw away again. Stellar neighborhoods are temporary arrangements. Our nearest neighbors are not permanent fixtures but fellow travelers. 2 paths that happen, for a while, to run alongside one another through an enormous dark. The 40th fact is that there is a kind of quiet poetry in the fact that our nearest neighbor was found by accident, by a man comparing photographs in the southern summer of 1915, while the rest of the world was consumed by war, No fanfare attended it. No headline announced it. A faint red dot on a glass plate simply moved a little more than it should have, and one careful observer noticed. The nearest star in the universe had been waiting there all along, patient and unremarked, and it took only someone willing to look twice at the same patch of sky. The 41st fact is that a red dwarf is simply a star that formed with very little material, and so never grew hot enough or bright enough to become anything grander. Stars are born from collapsing clouds of gas, and the amount of gas that happens to fall into a given knot determines everything about the star's future. Gather a great deal, and you get a blazing blue giant that burns furiously and dies young. Gather only a little, and you get something like Proxima Centauri, small and cool and almost unimaginably long-lived. The whole destiny of a star is fixed in the first moments of its making, and Proxima was made small. The 42nd fact is that Proxima Centauri carries roughly 12% of the mass of our Sun, which places it near the lower boundary of what can be called a star at all, below about 8% of a solar mass. An object simply cannot compress its core enough to fuse hydrogen, and it becomes a brown dwarf instead, a failed star that glows dimly from leftover heat and slowly fades. Proxima sits comfortably above that line, but not enormously so. It is a genuine star, but it came remarkably close to being something else entirely. A small margin decided long ago between shining and merely cooling. The 43rd fact is that despite being so much less massive than the Sun, Proxima Centauri is far denser, packing its material into a much tighter ball. Its radius is only about 14% of the Sun's, which means that if you shrank our Sun down to that size, its material would be squeezed roughly 40 times more tightly than it is now. Small stars are compact stars. Proxima is only slightly larger than the planet Jupiter in width, and yet it holds well over 100 times Jupiter's mass. It is a heavy, dense little coal. A spoonful of the material near its center would weigh more than anything you have ever lifted, pressed together by the weight of the whole star standing above it. Small in the hand, enormous on the scale. The 44th fact is that the interior of a red dwarf works quite differently from the interior of our Sun, in a way that turns out to matter a great deal. In the Sun, the core is separated from the outer layers, and energy travels outward first as radiation and only later by the churning of hot gas. But a small star like Proxima is fully convective, which means the entire body of it churns and circulates, from the very core out to the surface. The whole star is one great slow boiling pot, and everything inside it is continuously mixed. The 45th fact is that this complete mixing is why red dwarfs live for such staggering lengths of time. A star like our Sun can only burn the hydrogen sitting in its innermost core, perhaps 1/10 of its total supply, before the fuel there runs out and the whole structure begins to change. But a fully convective star circulates fresh hydrogen down into the burning core continuously, and so it can eventually consume nearly all the fuel it possesses. Proxima has access to its entire tank rather than a small reservoir at the bottom, and it burns from that tank very, very slowly. The 46th fact is that the expected lifetime of Proxima Centauri is measured not in billions of years, but in trillions. Estimates run to something on the order of 4 trillion years of steady hydrogen burning, which is roughly 300 times the entire present age of the universe. Nothing in the cosmos has yet had time to grow that old. Every red dwarf that has ever formed, anywhere, is still a young star, still in the earliest chapter of its enormous life. Proxima has barely begun. The universe itself is not yet old enough for a single one of these small red stars to have finished even the first chapter of its life, and it will still be shining unchanged long after every bright star in the sky has gone dark. The 47th fact is that the reason for this immense longevity is simply how gently a red dwarf burns. Fusion rates depend very steeply on temperature and pressure, and in a small, cool core the reactions proceed at a leisurely crawl. Proxima converts hydrogen to helium at a rate thousands of times slower than our Sun does. It is the difference between a bonfire and a single coal buried in ash. The bonfire is glorious and brief. The coal glows for an age. Our neighbor chose the coal, and will outlast everything glorious in the sky by a factor beyond ordinary counting. The 48th fact is that Proxima Centauri radiates only about 17,000% of the Sun's total energy output in visible light. The number is so small that it is easier to think of it another way. If our Sun were a bright household lamp, Proxima would be a single dim night light glowing on the far side of a large room. And yet, even that is a considerable amount of energy by any human measure. Faintness is entirely a matter of comparison. Against the Sun, it is nothing at all, and against the dark of interstellar space, it is a genuine and steady fire. The 49th fact is that most of the light Proxima Centauri emits is invisible to us, pouring out in the infrared rather than in the colors our eyes can register. Cool objects radiate at long wavelengths, and at 3000 Kelvin the peak of Proxima's output falls well past the red edge of human vision. If you had eyes that could see infrared, our nearest neighbor would appear far brighter than it does. Much of what that star gives to the universe simply passes through us unnoticed, warmth without light, pouring out into the dark in a color we were never built to see. The 50th fact is that Proxima Centauri is also a variable star, meaning its brightness changes over time in ways that can be measured. Part of that variation comes from the great flares it produces, which we will come to later, and part from enormous dark star spots turning slowly across its face as the star rotates. These spots are the same phenomenon as sunspots on our own Sun, cooler regions where magnetism has choked off the rising heat. On a small star, they can be proportionally enormous, covering a substantial fraction of the visible surface at once and dimming the entire star measurably as they turn slowly into view, great dark continents of shadow drifting across a small red face. The 51st fact is that Proxima Centauri turns on its axis roughly once every 83 days, which is remarkably slow for a star of its kind. Our own Sun rotates about once a month at its equator. Many red dwarfs spin far faster than either. Rotation matters enormously for a star because it drives the churning dynamo that generates magnetic fields, and magnetic fields drive flares and spots and all the restless behavior of stellar surfaces. Proxima turns lazily, and yet, as we will see, it still manages to be one of the most magnetically restless stars in our neighborhood. The 52nd fact is that the age of Proxima Centauri is estimated at somewhere near 5 billion years, making it a little older than our own Sun. But for a star that will live for trillions of years, 5 billion is a vanishingly small fraction of a lifetime. If you scaled its total existence down to a single human lifespan of 80 years, then all 5 billion years so far would amount to roughly the first 4 hours after birth. Proxima Centauri is, in every meaningful sense, a newborn, an infant star that has already been shining since before the Earth was formed. The 53rd fact is that when a red dwarf finally does exhaust its hydrogen, in trillions of years, it will not die in any dramatic way at all. Larger stars swell into red giants and shed glowing shells of gas, or collapse and explode as supernovae. Proxima will do neither. Theory suggests it will simply grow slightly hotter and bluer for a time as its helium accumulates, and then quietly contract into a white dwarf, a dense cooling ember, and fade away across further trillions of years. There will be no explosion, no final flourish, only a slow and gentle dimming into the dark. The 54th fact is that red dwarfs are so long-lived that no red dwarf has ever died, anywhere in the universe, since the universe began, The cosmos is not yet old enough. Every single one of these small red stars that has ever formed in every galaxy is still burning right now. They are the only class of star of which that can be said. In a universe full of endings, here is one category of thing that has never once ended. 100 billion small red fires in our galaxy alone, all of them still lit, none of them yet gone out. The 55th fact is that this longevity means the era of the red dwarfs has hardly begun, and will one day be the only era there is. In something like 100 trillion years, the last of the bright, heavy stars will have burned out and the last new stars will have formed. What will remain, for a very long time afterward, is a universe lit only by the dim red glow of small stars like Proxima Centauri, patiently burning through their long fuel. The final age of starlight will be a red one. Whatever exists then will live under small suns like this one, in a cosmos far darker and far calmer than the bright and crowded one we happen to have been born into, quiet, dim, and almost unimaginably long. The 56th fact is that because red dwarfs are so common and so long-lived, they may represent the most likely homes for life anywhere in the cosmos, purely by weight of numbers. 3 out of every 4 stars in the galaxy is one of these small red suns, and they endure for spans of time that dwarf everything else. If life needs time above all, then the red dwarfs offer more of it than any other kind of star. There is a real possibility that most of the living worlds that will ever exist will circle small red stars, which is one very good reason to be curious about our nearest neighbor. The 57th fact is that Proxima Centauri is so small that if you placed it at the distance of our own sun, it would look strange rather than familiar. It would appear only slightly wider than the sun does in our sky, but it would give off a fraction of the light, hanging there as a deep red disk in a dim and dusky sky. Noon would look like a very late evening. The world beneath would be dark and cold. Our eyes evolved under one particular star, and under another they would find even the daylight unrecognizable. The 58th fact is that the spectrum of a cool star like Proxima Centauri is enormously more complicated than that of the Sun, because its atmosphere is cool enough for molecules to survive. In hot stars, everything is torn apart into single atoms. In Proxima, whole molecules of titanium oxide and water vapor persist in the outer layers, each one absorbing light at hundreds of specific wavelengths. The result is a spectrum so densely crowded with absorption features that astronomers spent decades learning to read it properly. Where the light of our sun shows a few thousand clean dark lines, the light of Proxima shows a dense forest of them, overlapping and blurring into one another, a fingerprint of extraordinary complexity, written in the light of a very small fire. The 59th fact is that there is genuine water vapor in the atmosphere of Proxima Centauri, which sounds impossible for the surface of a star until you consider the temperature. At 3000 Kelvin, hot as that is by earthly standards, the bonds of a water molecule can just barely survive. So among the outermost layers of that little star there really are molecules of water, formed and shattered and formed again in the churning heat. Water on the surface of a star. One of those quiet facts that seems to belong to poetry rather than to physics, and yet is simply true. The 60th fact is that there is a deep and restful symmetry in the character of a red dwarf, for everything about it is small and slow and patient. It burns gently. It changes almost not at all. It will still be exactly as it is tonight when every constellation we know has dissolved and reformed 1,000 times over. Nothing about it hurries, and nothing about it is spent. As you lie there in the dark, you might let your own breathing slow toward that same unhurried rhythm. One small, steady fire that has all the time in the world, and no need to spend any of it. The 61st fact is that the distance to Proxima Centauri, written out in ordinary kilometers, comes to about 40 trillion. That is a 4 followed by 13 zeros, a number so large that writing it down does almost nothing to help you feel it. Our minds handle hundreds well, and thousands passably, and millions poorly, and beyond that we simply stop. 40 trillion kilometers is not a distance you can picture. It is a distance you can only approach sideways through comparisons, one small step at a time. And so, gently, that is what we will spend this next while doing. The 60-second fact is that a light year is not a measure of time, despite how it sounds, but a measure of distance, and a beautifully chosen one. It is simply how far light travels in 1 year, moving at very nearly 300,000 kilometers every second without ever slowing or resting. In a single second, light could circle the Earth 7.5 times. In a year, it covers about 9.5 trillion kilometers. And Proxima Centauri sits 4.25 of those years away from us, which is the shortest such journey to any star in the sky. The 63rd fact is that light from the moon reaches us in a little over 1 second, and light from the sun in about 8 minutes. Light from Jupiter takes roughly 40 minutes to arrive, and light from Neptune something over 4 hours. Everything in our entire solar system, every planet and moon and comet we have ever visited, sits within a few light hours of home. And then, past the edge of all of it, there is nothing at all for 4.25 light years. The step from our system to the nearest star is not a step at all. Everything familiar sits inside a few hours of light, and then the map simply runs out, and the next thing on it is 4.25 years away. It is a chasm 10,000 times wider than everything before it. The 64th fact is that a useful way to feel the distance is to shrink the whole solar system down to something you could hold. Imagine the sun as a large grapefruit sitting on a table. On that scale, the Earth would be a grain of sand about 15 meters away, and Neptune would be a small pea circling at nearly half a kilometer. And Proxima Centauri, on that same scale, would be a small cherry pit, placed 4,000 kilometers away, roughly the distance from New York to the coast of California. The 65th fact is that this is the single most important thing to understand about interstellar space, and it is almost always left out of the pictures. In every illustration of the galaxy, the stars are drawn close together, crowded and companionable. In reality, they are separated by gulfs so vast that a scale model would have to place them thousands of kilometers apart. The galaxy is not crowded. The galaxy is very nearly empty, with a few tiny fires scattered through an enormous darkness. And Proxima, our very nearest neighbor, is 4,000 kilometers away on the grapefruit table. And it is the closest one there is. The 66th fact is that if you tried to walk to Proxima Centauri at an ordinary strolling pace of 5 kilometers an hour, without ever stopping to rest or sleep or eat, the journey would take about 900 million years. Life on Earth would have had time to evolve from simple soft-bodied creatures in the sea to everything that exists today twice over while you walked. It is a nonsensical calculation, of course, since there is nothing to walk upon. But nonsense of that kind is useful. The mind cannot hold 40 trillion kilometers in any honest way, and yet it can hold the idea of walking and of never once arriving. It gives the number a shape, and the shape is unimaginably large. The 67th fact is that a commercial airliner, cruising steadily at 900 kilometers an hour, would need something over 5 million years to reach the nearest star. That is longer than the entire history of the human family, from the first upright walkers to tonight. And an airliner is a fast thing. Crosses an ocean while you sleep. It carries you from one continent to another between breakfast and dinner. Against the scale of the stars, it is barely moving at all, which tells you something not about airplanes but about the size of the dark between the suns. The 68th fact is that even a rifle bullet, traveling at something near a kilometer every second, would take more than 1,000,000 years to cross the gap. Speeds that are dazzling on Earth become almost meaningless at interstellar scale. A bullet crosses a room before you can blink. It would cross the distance to Proxima Centauri in roughly the time it took for the first stone tools to become the first cities, repeated hundreds of times over. Everything fast that we know is slow out there. Space does not care about our records. It simply keeps being very, very large. The 69th fact is that the vast majority of that 40 trillion kilometers is completely and perfectly empty. Between our solar system and Proxima Centauri, there are no planets we know of, no dust clouds of any consequence, nothing but a scattering of individual atoms of hydrogen drifting in a near-perfect vacuum. In some regions, the density falls to fewer than 1 atom in every cubic centimeter, which is emptier than any vacuum ever produced in a laboratory on Earth. The road to our nearest neighbor is, in the truest sense, a road through nothing, uninterrupted, unmarked, and unimaginably long. The 70th fact is that our own solar system does not end sharply at Neptune, but trails off gradually into a vast cloud of icy bodies called the Oort cloud. That cloud may extend outward as far as 1 or even 2 light-years from the Sun, which means that a traveler bound for Proxima Centauri would spend perhaps the first quarter of the journey still technically within the Sun's domain. The edges of things in space are not edges but fadings. Home does not end at a wall. There is no border to cross out there and no sign to read, only a slow thinning of everything familiar until at last nothing familiar is left. It simply grows thinner and thinner until at last you notice it is gone. The 71st fact is that it is even possible that the Oort cloud of our Sun and any similar cloud around Alpha Centauri brush faintly against one another somewhere in the middle. If both systems carry such halos of icy debris out to 1 or 2 light-years, then the 4¼ light-years between us might be very nearly spanned. In that case, there would be no true gap at all, only an enormously thin overlap of 2 enormously thin clouds. Our neighborhood might, in the faintest possible sense, touch theirs, an almost imperceptible handshake across the dark. The 72nd fact is that if you shrank the entire distance from the Sun to Proxima Centauri down to the length of a single football field, the whole of our solar system out to Neptune would occupy less than the width of your thumb. Everything humanity has ever visited, every world we have photographed, every place our machines have landed, would fit inside that thumb width. The other 100 yards would be empty. That is the honest proportion of things. Our entire cosmic address on the scale of one single step between neighbors is a fingertip, and the rest is dark. The 73rd fact is that the distance to Proxima is often used as the standard unit of interstellar loneliness, and for good reason. It is the shortest possible example of a journey between stars, the easiest case, the closest hop. Every other star is farther. Sirius is twice as distant. The center of our galaxy is 6,000 times farther still. And even the shortest hop defeats every vehicle we have ever built. If interstellar travel is ever to be more than an idea, it must begin here, with the nearest, gentlest, most forgiving version of the problem. The 74th fact is that light itself, the fastest thing that exists, still needs 4 years and 3 months to make the crossing. Nothing can go faster. That is not a limit of engineering but a property of the universe, woven into the structure of space and time themselves. So a message sent tonight from the Earth toward Proxima Centauri would not arrive until more than 4 years from now, and any reply could not reach us for 4 years beyond that. The shortest possible conversation with our nearest neighbor takes most of a decade, and the universe offers no way around it. The 75th fact is that this delay changes the very nature of what a conversation could be, in a way that is worth sitting with quietly. You could not exchange greetings. You could only send a message and then live your life for 8.5 years before learning whether anything came back. Every question would be answered by a different version of yourself. Communication across interstellar space is not talking at all, but something closer to letter writing across generations. Slow, patient, and requiring a kind of faith we have almost forgotten how to practice. The 76th fact is that the emptiness between the stars is not entirely nothing, for it is threaded through with faint magnetic fields, drifting atoms, and a constant sleet of cosmic rays. These are particles flung outward by ancient exploding stars, traveling at nearly the speed of light, crossing the galaxy in every direction. They pass through the space between us and Proxima continuously, and through the Earth and through you at this very moment. The dark between the stars is quiet, but it is not still. There is always something crossing it, always some faint traffic of particles and fields moving through the emptiness on errands that began millions of years ago. It hums very faintly with the leftovers of old violence. The 77th fact is that if the sun were a single grain of sand, and you scattered stars across the entire volume of the Earth at their true relative spacing, you would place only a few dozen grains inside the whole planet. That is how empty the galaxy truly is. The images we make of star fields, dense with light, are illusions of perspective, the way a distant forest looks solid from far enough away. Stand among the trees and you find enormous spaces between them. We stand among the stars right now, and the spaces are almost everything there is. The 78th fact is that this emptiness, unsettling as it can seem, is also one of the great safeguards of life on Earth. Stars almost never collide. Systems almost never disrupt one another. Our solar system has circled the galaxy some 20 times without a single close encounter serious enough to scatter the planets. The vast distances that make travel so difficult are the very same distances that have kept us undisturbed for 4.5 billion years. What isolates us also protects us, and the emptiness that keeps us apart is the emptiness that keeps us safe. The 79th fact is that no human being will ever have a direct sensory experience of interstellar distance, and there is a kind of peace in accepting that we can compute it, model it, shrink it into diagrams, and speak it aloud in numbers. But we cannot feel it, and we were never built to. Our bodies understand the length of a walk, the reach of a voice, the span of a day. 4.25 light years is not a thing the mind can hold. And there is no failure in that, no shortcoming to be corrected, since no mind that has ever existed was shaped to hold such a thing. Only a thing the mind can respectfully approach and then set gently down. The 80th fact is that there is something restful, rather than frightening, in a distance too large to grasp. It cannot be crossed tonight, and so there is nothing to be done about it, and nothing whatever that it asks of you. Between you and the nearest star lies 40 trillion kilometers of perfectly quiet emptiness, and every one of those kilometers is peaceful. Nothing is happening out there. Nothing is coming. Let that great soft emptiness settle around you like a blanket, a vast and gentle nothing, holding the whole world safely in the middle of it. The 81st fact is that in August of 2016, astronomers announced that Proxima Centauri has a planet, and the news traveled around the world in a single day. For centuries, the nearest star had been simply a star, a point of light with nothing attached to it. And then, quite suddenly, it had a world. The planet was given the plain designation Proxima b, following the convention that the star itself is A and the first planet found is B. It was and remains the closest planet to the Earth outside our own solar system, a world orbiting the very next star along. The 82nd fact is that Proxima b was found not by seeing it, but by watching the star wobble. A planet does not simply orbit its star. The two of them orbit their common center of mass, and so the star traces out a small circle of its own in response to the planet's pull. That motion shifts the star's light very slightly toward the blue as it approaches us and toward the red as it recedes. The shift for Proxima amounts to about 1.5 meters per second, roughly walking pace. To measure a motion that gentle across 4 light-years of empty space is an achievement that would have seemed like plain magic to the astronomers of a century ago. A whole star, betrayed by a movement no faster than a stroll. The 83rd fact is that the campaign that found the planet was given the lovely name Pale Red Dot, a deliberate echo of Carl Sagan's famous description of the Earth as a pale blue dot. Astronomers watched Proxima Centauri every clear night for months from an observatory in the Chilean desert, using an instrument of extraordinary precision. They also published their progress publicly as they went, which was unusual and rather brave. The whole world watched a discovery unfold in something close to real time, and at the end of it there was a planet. The 84th fact is that Proxima b has a minimum mass of about 1.07 times the mass of the Earth, which makes it one of the most Earth-like worlds by mass that we have ever detected. The method used gives only a minimum, because it cannot tell how the orbit is tilted relative to our line of sight, and a tilted orbit would imply a somewhat heavier planet. But the most likely value remains close to the mass of our own world. Somewhere out there, at the nearest star, is a planet that weighs almost exactly what the Earth weighs. The 85th fact is that Proxima b completes one full orbit of its star in only 11.2 days, which means its entire year is shorter than 2 of our weeks. A person living there, if such a thing were possible, would celebrate a birthday roughly 33 times in every earthly year. The seasons, if there were any, would flash past. Everything about the calendar would be compressed into something almost unrecognizable. The nearest planet to us keeps a clock so fast that our own year would contain more than 30 of theirs. Everything we mean by a year, every season and anniversary and slow turning of the calendar, would have to be rebuilt there from the ground up. An entire lifetime of orbits inside a single human decade. The 86th fact is that Proxima b orbits astonishingly close to its star, at only about 0.0485 astronomical units. That is under 5% of the distance from the Earth to the Sun, which places it roughly 7 million kilometers from the surface of Proxima Centauri. For comparison, Mercury, the innermost planet of our own system, orbits at nearly 8 times that distance and is scorched to a cinder. Proxima b sits far closer to its Sun than any world in our system sits to ours. And yet it is not scorched at all, for reasons that make the whole story interesting. The 87th fact is that the reason such a close orbit is survivable is simply that Proxima Centauri is so faint. A world at that distance from our Sun would be vaporized within moments. But Proxima gives off less than a 500th of the Sun's energy, and so a planet must huddle in very close indeed to receive a comfortable amount of warmth. Proxima b receives roughly 2/3 of the sunlight that the Earth receives, which is not so very different from what Mars gets from our own Sun, a small fire and a world drawn near to it. The 88th fact is that this places Proxima b squarely inside what astronomers call the habitable zone, the band of orbits around a star where the temperature would allow liquid water to exist on a planet's surface. It is sometimes called the Goldilocks zone for the obvious reason. Too close and any water boils away. Too far and it freezes solid. Proxima b sits within that band, which is the single most exciting thing about it. The nearest planet to our own solar system happens to orbit at exactly the distance where an ocean could survive, which is a remarkable piece of luck. The 89th fact is that being in the habitable zone is not at all the same thing as being habitable, and astronomers are careful to say so. The habitable zone is defined by distance and starlight alone, and it says nothing about whether a planet has an atmosphere or water, or a magnetic field, or a stable climate. Venus sits at the inner edge of our own habitable zone and is a furnace. Mars sits near the outer edge and is a frozen desert. The zone is only the address. It tells you that a world sits on a promising part of the street and nothing whatever about what has actually been built there. It says nothing at all about the house. The 90th fact is that we do not know whether Proxima b has an atmosphere, and that single unknown governs almost everything else about it. With a thick atmosphere, heat would circulate around the planet and the surface could be mild and temperate. With no atmosphere, it would be a bare rock, blazing on one side and frozen on the other. Every question about oceans, about climate, about the possibility of anything living there waits behind that one question, and we cannot yet answer it, though we are slowly and patiently building the instruments that might. The 91st fact is that Proxima b is very likely a rocky world rather than a ball of gas, based on what we know of its mass. Planets much heavier than a few times the Earth's mass tend to gather thick envelopes of hydrogen and helium and become small gas giants. At just over 1 Earth mass, Proxima b almost certainly sits below that threshold. So we are probably speaking of a solid world with a surface, with ground beneath, with mountains or plains or seas of some kind. Not a cloud, but a place. The nearest other place there is. The 92nd fact is that if Proxima b has an Earth-like composition, its surface gravity would be very close to our own, perhaps only slightly stronger. A person standing there would weigh roughly what they weigh at home. They could walk and jump and stand, and it would all feel familiar in the body even while everything overhead was utterly strange. Of all the worlds we have discovered beyond our solar system, this is one of the very few where the simple act of standing up would feel almost exactly as it does here. The 93rd fact is that despite everything we know about it, no one has ever seen Proxima b, not even as a single pixel of light. Its existence is inferred entirely from the motion of its star. It is far too close to Proxima and far too faint for any telescope we possess to separate the two. Everything we say about it comes from mathematics applied to a wobble. We are quite certain it is there, and we know its year and roughly its weight, and we have never once laid eyes upon it. There is something almost old-fashioned about that kind of knowledge, arrived at by careful reasoning rather than by looking, a world known entirely by its effects. The 94th fact is that, unlike many planets found around other stars, Proxima b does not appear to pass in front of its star as seen from Earth. When a planet does transit its star, it blocks a tiny fraction of the light, and that dimming reveals the planet's size and even, sometimes, the composition of its atmosphere. Astronomers searched carefully for such transits at Proxima and did not find them, which means the orbit is tilted away from our line of sight. It is a genuine misfortune of geometry, a door that happens to be closed by the accident of our viewing angle. The 95th fact is that the surface temperature of Proxima b, if it has no atmosphere at all, would average around -40 degrees Celsius, well below freezing across most of the globe, but atmospheres change everything. Our own Earth, without its air, would average about 18 degrees below freezing rather than the comfortable 15 above that we actually enjoy. A modest greenhouse effect on Proxima b could lift its temperature into a range where liquid water flows freely. The planet sits right on the knife edge, and which side it falls on depends entirely on its air. The 96th fact is that some models suggest Proxima b could hold an ocean, though very likely not one spread evenly across the whole world. If the planet always keeps the same face toward its star, the water might be gathered into a single great sea on the sunlit side, or trapped as ice everywhere else. Other models suggest a narrow band of open water in a ring around the world. These are not observations but careful imaginings, constrained by physics. Somewhere between them may lie the truth of a real place, which no one has ever seen. The 97th fact is that Proxima b is the closest exoplanet to the Earth, and will almost certainly remain so for as long as human beings are counting. There is simply no closer star for a planet to orbit. Every other world beyond our solar system, of the thousands now catalogued, is farther. If humanity ever sends a machine to another star's planet, this is the one it will go to, for the plain and unanswerable reason that there is nothing nearer. It is the first door in a very long corridor, and it happens to be the only one within reach. The 98th fact is that the discovery of Proxima b changed how people speak about interstellar travel almost overnight. Before it, the idea of sending anything to another star was an abstraction, a destination without a purpose. Afterward, there was somewhere specific to go, a real world of roughly Earth's weight sitting in the habitable zone of the nearest star in the sky. Ideas that had been quiet curiosities in the back pages of journals suddenly acquired a target. Having a destination changes everything about a journey, even a journey no one yet knows how to make. The 99th fact is that it is worth pausing on how extraordinary the timing of all this is. In the long story of our species, for 100,000 years, human beings looked up at the stars and had no way of knowing whether any of them held worlds. And then, within a single generation, we learned that they nearly all do, and that the very nearest one holds a planet about the size of our own. That question, asked around every campfire in history, was finally answered in our own lifetimes. Of all the generations that have ever looked up at the sky, ours is the first to know that the nearest star has a world of its own. Quietly, from a mountaintop in Chile. The 100th fact is that on any given night, the nearest planet outside our solar system is quietly completing another of its 11-day years, sweeping around its small red sun without the slightest awareness of us. It has been doing so for billions of years, long before anyone here thought to look for it, and it will go on doing so long after. There is nothing to be done about it and nothing to be worried over. It simply turns, faithfully and silently, in the dark. And so does the world you are lying upon tonight. The 101st fact is that Proxima Centauri is not a star with a single planet, but a small system of at least 2 worlds and possibly 3. In February of 2022, astronomers confirmed the existence of a second planet, given the designation Proxima d. It had been suspected for some time from faint hints in the data, and finally, after years of patient observation, the signal became firm enough to announce. The nearest star to the Sun turns out to have a family, which is either an astonishing coincidence or, far more likely, an indication that families of worlds are simply ordinary. The 102nd fact is that Proxima d is one of the lightest planets ever detected around any star, carrying only about a quarter of the mass of the Earth. The precise figure is near 0.26 Earth masses, which is roughly twice the mass of Mars. Detecting the pull of such a small world on its star required measuring a stellar motion of about 40 centimeters per second, which is slower than a person shuffling across a room. That astronomers can measure the speed of a star for light years away, to that precision is one of the quiet marvels of modern instruments. The 103rd fact is that Proxima d orbits even closer to its star than Proxima b, completing one circuit in just 5.1 days. Its year is barely longer than a working week. It sits at roughly 1/25th of the distance from the Earth to the Sun, well inside the habitable zone and far too warm for liquid water to survive on its surface. It is a small, hot, tightly wound world, whipping around its little red sun again and again while almost nothing on the Earth has time to change. In the time it takes a single season to turn here, that little planet has lived through a whole handful of its own years, 71 years of its life for every one of ours. The 104th fact is that there is a third possible world in the system, a candidate known as Proxima c, whose existence remains uncertain even now, the evidence suggests a planet of perhaps 7 times the Earth's mass, orbiting far out from the star on a leisurely path taking about 5 years to complete. Some observations support it and others do not, and the signal is difficult to disentangle from the star's own restless magnetic cycles. It hovers in that honest middle ground where science often lives, probably there, not yet certain, waiting patiently for better data. The 105th fact is that if Proxima C is real, it would be a very cold world indeed, far outside the habitable zone and receiving only a tiny trickle of light from its star. Some astronomers have speculated that such a planet might be surrounded by a great ring of dust, which could reflect enough sunlight to make it faintly visible to future telescopes. There is even a chance that it could one day be photographed directly. If so, it would be the first planet of another star ever seen as an actual image rather than inferred. A real portrait of a real world. The 106th fact is that finding several planets around a small red dwarf fits a pattern astronomers have been noticing for years. Red dwarfs appear to form planets readily, often several of them, packed into tight orbits close to the star. The famous system called TRAPPIST-1, another small red star, holds 7 roughly Earth-sized worlds all orbiting closer to their sun than Mercury orbits ours. Small stars seem to build small, crowded, tidy systems. Ours, with its widely spaced giants, may be the unusual arrangement, and the compact red dwarf systems may be the ordinary way of things. The 107th fact is that Proxima b is almost certainly tidally locked to its star, which means it keeps one face turned permanently toward the light. This happens because the star's gravity pulls slightly harder on the near side of the planet than on the far side, and over millions of years that difference drags the rotation into step with the orbit. Our own moon is locked to the Earth in exactly this way, which is why we have never seen its far side from the ground. Proxima b turns once for every orbit it makes, and so its day and its year are the same thing. The 108th fact is that a tidally locked world would have no sunrise and no sunset anywhere upon it. Ever. On the day side, the small red sun would hang motionless in the sky, never rising, never setting, never moving from its appointed place. On the night side, there would be no sun at all, only permanent darkness and the stars. There would be no dawn to wake to and no dusk to rest by. Every rhythm we have built our lives around would simply be absent. There would be no morning and no evening, no hour of the day at all, only the place where you happen to be standing. One endless afternoon on one side, one endless night on the other. The 109th fact is that if you stood on the day side of such a world, the position of the sun in your sky would tell you exactly where you were. At the point nearest the star, the sun would sit directly overhead, unmoving. Walk in any direction and it would sink lower. Keep walking, and eventually it would rest exactly on the horizon, half above and half below, forever. Beyond that line lies permanent night. Geography and time of day would become the same thing. Your location written in the sky above you, never changing. The 110th fact is that the boundary between the eternal day and the eternal night has a name that has captured a great many imaginations. The Terminator, or more poetically, the ring of eternal twilight. It would be a band of perpetual sunsets circling the entire world, where the star sits low and red on the horizon and the light is soft and slanted and golden. If any part of such a planet were comfortable, this ring might be it. A narrow habitable belt of endless evening, wrapped around a world like a ribbon. The 111th fact is that on the night side of a tidally locked world, the stars would never move at all. There would be no rising and no setting, no wheeling of the constellations across the hours. The same stars would hang in the same places, permanently fixed, for as long as anyone cared to look. Every night sky we have ever known turns slowly overhead, and every culture has built stories and calendars and whole systems of navigation from that turning. On such a world there would be no turning at all, and no way to tell 1 hour from the next by looking up, only a single fixed picture, beautiful, unchanging, and profoundly strange. The 112th fact is that without an atmosphere to carry heat around it, a tidally locked planet would suffer an extreme division between its two faces. The day side would grow steadily warmer under its unmoving sun, while the night side would radiate its heat into space for eons and fall toward temperatures cold enough to freeze the air itself. All the water and all the gases would eventually migrate to the cold side and settle there as ice and snow. The planet would slowly strip its own day side bare, unless the winds were strong enough to prevent it. The 113th fact is that with even a modest atmosphere, the picture changes completely, and this is where the models grow genuinely hopeful. Air is a remarkably effective carrier of heat, and a planet with a reasonable envelope of it would develop enormous circulation patterns, hauling warmth from the day side around to the night side continuously. Some simulations suggest that with an atmosphere similar in thickness to our own, the temperature difference between the two faces of Proxima b could be modest rather than extreme, a whole world made livable by nothing more than wind. The 114th fact is that the weather on such a world would be like nothing on Earth, and the models predict something quite specific and strange. Directly beneath the unmoving sun, hot air would rise continuously in one enormous permanent storm, a single vast column of cloud anchored to one spot for millions of years. From orbit you would see a great white eye of cloud sitting always at the same point on the globe, with clear skies spiraling away from it. One storm, never moving, never ending, a fixed feature of the planet like a mountain made of weather. The 115th fact is that this permanent cloud cover directly beneath the star might be one of the most important things protecting such a world. Bright white cloud reflects sunlight back into space very efficiently, and a thick cap of it sitting exactly where the star shines hardest would keep the surface far cooler than it would otherwise be. The planet would, in effect, be shading itself. Climate systems have a way of finding these balances. A world can be its own parasol. The more fiercely the star shines upon that one spot, the thicker the cloud above it grows, and the more of the light is turned quietly away again before it ever reaches the ground. And Proxima b may well be holding one over its own head. The 116th fact is that tidal locking need not be perfectly exact, and a slightly eccentric orbit can produce something gentler called a spin-orbit resonance. Mercury, in our own system, does not keep one face toward the Sun but instead rotates precisely 3 times for every 2 orbits, so that its day is long but not infinite. Proxima b might well have settled into a similar arrangement. In that case it would have real days and real nights, extremely long ones but genuine ones, a slow, sweeping cycle of light and dark rather than a frozen sky. The 117th fact is that if Proxima b does have such a resonance, its day would last something like 7.5 Earth days from one sunrise to the next. The star would creep across the sky with extraordinary slowness, taking most of a week to travel from one horizon to the other. Dawn would last for hours. Sunset would last for hours more. Every shadow on that world would move so slowly you could sit and watch it and never quite see it change. A day unfolding at the pace of a season. The 118th fact is that the sun in the sky of Proxima b would look enormous, far larger than ours ever appears from the Earth. Because the planet orbits so close in, its star would span roughly 3 degrees of sky, about 6 times the width of the sun as we see it, a great dim red disk hanging above the landscape. It would not be blinding. You could very likely look straight at it. A huge, soft, deep red circle sitting motionless in the sky. more like a permanent sunset than anything we would call daylight. The 119th fact is that the light falling on such a world would give everything a color we have no real word for. The star radiates most strongly in the deep red and the infrared, so every surface would be lit as though by embers. Green plants, if any existed there, would very likely not be green at all, since there would be almost no blue light for them to reflect away. They might be black, absorbing every scrap of what little energy arrived. A landscape of dark leaves under a red, unmoving sun, with shadows that never shorten and never lengthen, and never once change their direction across an entire afternoon that has no end. Alien, and rather beautiful. The 120th fact is that of all the strange features of these nearby worlds, the one that stays with me is the stillness of their skies. No sunrise, no sunset, no wheeling stars, no moving shadows, only a great red sun holding perfectly still above a quiet landscape, and a permanent dusk on the far horizon. It is a picture of enormous calm. Nothing there hurries, and nothing there changes, and nothing there has changed for a very long time, which is perhaps a rather good thing to carry with you towards sleep. The 121st fact is that Proxima Centauri belongs to a class of stars that astronomers call flare stars, and it is one of the more energetic examples nearby. A flare star is one that occasionally brightens sharply and suddenly, sometimes doubling or tripling its output within minutes, before fading back to normal over the following hour. Our own sun does something similar, but on a scale so modest by comparison that we barely notice it from the ground. On a small red star, the same process produces something far more dramatic, a quiet ember that occasionally blazes. The 122nd fact is that these flares happen because of magnetism, and magnetism in a star is generated by the churning of its own interior. In a fully convective star like Proxima, that churning is constant and vigorous throughout the whole body of the star, and it tangles the magnetic field into knots and loops that thread up through the surface. Now and then, two of those loops snap and reconnect, releasing an enormous burst of stored energy all at once. It is the same physics that produces solar flares on our own Sunday. A magnetic field can store an extraordinary amount of energy in its tangles, and when a tangle finally gives way, all of that stored energy comes out at once, only far more frequent and far larger in proportion. The 123rd fact is that in March of 2019, telescopes recorded a superflare from Proxima Centauri that stands among the most extreme ever seen from a nearby star. For a few seconds, the star's brightness in ultraviolet light rose by a factor of some 14,000. The event was caught by several observatories at once, watching in radio, in visible light, and in ultraviolet, which made it one of the best documented stellar flares in history. The whole thing lasted only seconds, and in those seconds, our quiet little neighbor became something entirely different. The 124th fact is that this superflare was so bright that, had you been watching Proxima Centauri through a small telescope at that exact moment, you would have seen it jump briefly into visibility. A star that normally requires serious equipment to detect it all would have flashed up toward the edge of naked eye brightness for a matter of seconds and then subsided. Astronomers have recorded such moments before, but never quite so vividly. The nearest star to the sun, invisible on every ordinary night, blinked once, and then went back to hiding. The 125th fact is that a flare of this magnitude releases most of its energy in ultraviolet and X-ray light rather than in visible colors. This matters enormously because it is precisely those short, energetic wavelengths that do damage to atmospheres and to the delicate chemistry of anything living. A flare that a human eye might barely register can be devastating in the invisible part of the spectrum. What appears to be a brief flicker to us can be a very serious event indeed for any world nearby. Which brings us inevitably to Proxima b. The 126th fact is that Proxima b, orbiting so very close to its star, receives the full force of every one of these flares. Because it sits at only 5% of the distance from the Earth to the Sun, the energy that reaches it from a flare is hundreds of times more intense than the same flare would deliver at our distance. Estimates suggest that during a large event, the planet could receive several hundred times the ultraviolet dose that the Earth ever experiences from our own Sun's worst outbursts. It is a small world, sitting very close to a restless fire, near enough that every twitch and shudder of that fire arrives at full strength on the ground below. The 127th fact is that the chief concern with such flares is not the light itself but what it does to a planet's atmosphere over long spans of time. Intense ultraviolet radiation breaks apart molecules in the upper air, and the resulting fragments are light enough to escape into space. Over hundreds of millions of years, a planet subjected to repeated flaring could lose a great deal of what it started with. It is not a catastrophe in any single moment. It is an erosion, slow, patient, and cumulative like water working on stone. The 128th fact is that flares are frequently accompanied by something even more consequential, an outward hurl of charged particles that astronomers call a coronal mass ejection. These are enormous clouds of stellar material flung out into space at high speed. And when one strikes a planet directly, it can strip away air far more efficiently than radiation alone. Our own Earth is shielded from such things by its magnetic field, which deflects the incoming particles around us. Whether Proxima b has any such shield is unknown, and it may be the single most important unknown about it. The 129th fact is that a planet's magnetic field is generated by molten metal circulating deep in its core, and it requires the interior to stay hot and fluid over billions of years. The Earth has managed this, and Mars did not, which is a considerable part of why Mars lost most of its atmosphere long ago. Whether a tidally locked world can maintain a strong magnetic field is debated, since slow rotation may weaken the internal dynamo. The answer would decide the fate of an entire planet, and we simply do not have it yet. The 130th fact is that Proxima Centauri produces small flares remarkably often, several times a day in fact, though the great ones are rare. Continuous monitoring has shown the star flickering upward again and again, mostly by small amounts, as its tangled magnetism releases pressure in little bursts. It is a restless star in a way that our own Sun simply is not. If you could watch Proxima with the right instruments night after night, you would rarely see it perfectly still. Most of these small events would pass entirely unnoticed by any eye, registering only as faint wiggles in a graph drawn by a patient machine. A quiet ember, constantly shifting and settling and sparking. The 131st fact is that this restlessness is somewhat unexpected in a star that rotates as slowly as Proxima does. For most stars, magnetic activity fades as rotation slows with age, and an 83-day rotation period ought to belong to a calm and settled star. Proxima breaks that rule. The likely explanation is that full convection throughout the star's body generates magnetism by a different mechanism than in a Sun-like star, one that does not depend so heavily on spin. Small stars, it turns out, play by their own rules and remain lively far longer than we might expect. The 132nd fact is that Proxima Centauri also has a magnetic cycle of its own, a rhythm of activity rising and falling over roughly 7 years. Our Sun has an 11-year cycle, in which sunspots grow numerous and then vanish and then return. Proxima follows a similar pattern on a somewhat shorter beat. Over about 7 years, the flaring grows more frequent and then subsides again, breathing in and out across the decades. Even the most restless star has a rhythm, and even that rhythm is slow enough to be measured in years rather than moments. The 133rd fact is that not every consequence of stellar flares is destructive. and some researchers have argued they may even be helpful in certain ways. Ultraviolet light drives many of the chemical reactions thought to be involved in the origin of life, and a red dwarf in its quiet moments gives off very little of it. A world that received a periodic dose from flares might have the chemistry it needs to get started, rather than sitting in a dim and unreactive calm. The same fire that erodes may also kindle, which is very often how these things work. The 134th fact is that a thick atmosphere would go a very long way toward protecting the surface of a planet from flare radiation. Whatever happens in the upper layers, our own air absorbs virtually all incoming ultraviolet before it reaches the ground, which is why life on Earth is possible outside the ocean at all. A world with a substantial atmosphere could keep its surface entirely sheltered even while its outermost layers were being slowly worn away. Depth is protection, and a few hundred kilometers of air is a very effective wall. The 135th fact is that water is an even better shield than air, and this is one of the most hopeful thoughts about worlds around flare stars. A few meters of water absorbs virtually all ultraviolet radiation, and a few tens of meters absorbs nearly everything else. Anything living beneath the surface of an ocean on Proxima b would be entirely untroubled by even the fiercest flare. Life on Earth spent its first several billion years in exactly that situation, sheltered under the sea while the surface above remained hostile. It came ashore only long afterward, once the air had been made safe by the living things below, which suggests the arrangement is not merely survivable but rather ordinary. The 136th fact is that the flares of Proxima Centauri would produce aurorae on any planet with a magnetic field, and they would be spectacular beyond anything on Earth. Our own northern lights are caused by particles from the sun funneling down toward the poles and setting the upper air aglow. At Proxima b, with far more intense particle storms arriving far more often, the aurorae could be brilliant enough to light the entire night side of the world. Imagine a sky that never sees the sun, but glows continually in shifting curtains of green and red. The 137th fact is that astronomers have been able to study the flares of Proxima Centauri in extraordinary detail precisely because it is so close. A flare from a distant red dwarf is a faint blip in a noisy signal. A flare from Proxima is a clear, well-resolved event that several telescopes can watch simultaneously across many wavelengths. Nearly everything we understand about the behavior of small flare stars has been refined against this one example. It is our reference case, our teacher, the one small red star we can genuinely watch in detail. The 138th fact is that none of this activity has any effect whatsoever upon the Earth, and it is worth saying so plainly. Even the greatest superflare Proxima has ever produced arrives here as an utterly negligible whisper, thinned by 4¼ light-years of distance until it is far weaker than the light of the faintest stars. Nothing that happens at Proxima Centauri can reach us in any meaningful way. It could flare 1,000 times tonight and no instrument on Earth would register anything but a small change in a number, and no living thing would notice at all. The 139th fact is that we happen to be watching Proxima Centauri during an interesting chapter of its enormous life, and that too is a matter of luck. Red dwarfs are known to be most magnetically active when they are young, and to settle gradually into calm over billions of years. Proxima, at perhaps 5 billion years old, is still in its restless phase, but that phase is a small fraction of a life measured in trillions. Ahead of it lie unimaginable ages of quiet, trillions of years in which the flaring will fade away to almost nothing and the little star will simply burn, evenly and without incident, and whatever worlds it holds will spend nearly all their existence in peace. The 140th fact is that there is something oddly comforting in a star that flares and then settles, again and again, across the ages. It brightens for a few seconds, and then returns to its long, slow burning as though nothing had happened at all. Nothing is broken by it. Nothing is lost that matters. The star simply carries on. As you lie in the dark tonight, you might let your own small flares of thought rise and fade in the same way. A brief flicker, and then quiet again, and then quieter still. The 141st fact is that the fastest object humanity has ever sent beyond the solar system is a small spacecraft called Voyager 1. Launched in 1977, it is now more than 24 billion kilometers from home, farther than any other made thing has ever traveled, and it is still moving outward through interstellar space at roughly 17 kilometers every second. That is more than 60,000 kilometers an hour, a speed no vehicle on Earth could ever approach. And yet, against the distance to the nearest star, even that extraordinary speed reveals itself as almost nothing at all. The 142nd fact is that if Voyager 1 were pointed directly at Proxima Centauri and simply allowed to coast, it would need something like 73,000 years to arrive. 73,000 years ago, the last ice age had not yet reached its deepest cold, and modern humans were only beginning to spread out from Africa across the wider world. That is the length of the journey, at the greatest speed we have ever achieved with anything. Not a lifetime, not a dynasty, not a civilization, something closer to the entire span of human history, several times over, to reach the very nearest star. The 143rd fact is that Voyager 1 is not, in fact, headed toward Proxima Centauri at all, nor toward any star in particular. It is drifting off in the general direction of the constellation Ophiuchus, and its closest approach to any known star will come in about 40,000 years, when it passes within roughly 1.5 light-years of a small red dwarf called Gliese 445. Even that will not be an encounter in any meaningful sense. It will simply pass through the same broad region of dark, and then continue onward forever. The 144th fact is that Voyager 1 has been traveling for nearly half a century and has covered less than 1,000th of the distance to the nearest star. Say that number again slowly. 48 years of continuous travel at 60,000 kilometers an hour without ever slowing or stopping, and it has crossed less than 0.1% of the way. This is the honest measure of the interstellar problem. Our very greatest achievement in distance is, on the scale of the stars, barely a step off the porch. The door is still in sight behind us, and the road ahead has not properly begun. The 145th fact is that Voyager's speed was not the product of a powerful engine but of a clever piece of celestial billiards called a gravity assist. The spacecraft flew close past Jupiter and then Saturn, and each time it stole a small amount of the planet's orbital momentum, whipping outward faster than it arrived. It is a beautiful trick, essentially free, and it is how nearly every deep space mission gains its speed. But the trick has limits. There are only so many planets to borrow from, and Voyager borrowed from the best of them. The 146th fact is that the fastest human-made object ever measured in raw speed is not Voyager but the Parker Solar Probe, which dives repeatedly toward the Sun. At its closest approaches, it reaches something near 700,000 kilometers an hour, which works out to about 190 kilometers every second. It is by far the swiftest thing our species has ever built. But that speed is borrowed from falling toward the Sun, and the probe is not going anywhere except around, and it will never carry that speed outward into the dark. The 147th fact is that even if you could somehow send the Parker Solar Probe toward Proxima Centauri at its very fastest speed, the journey would still take about 6,500 years. That is longer than all of recorded history. Writing was invented roughly 5,000 years ago. A ship launched at the dawn of writing, at the greatest speed our technology has ever achieved, would still be well short of arrival tonight. This is the fastest we can go, and it is still not remotely fast enough. which is a rather sobering piece of arithmetic. The 148th fact is that chemical rockets, the kind that lift everything we launch, are fundamentally incapable of interstellar travel, and the reason is a matter of simple mathematics. A rocket must carry the fuel it will burn, and that fuel has weight, which requires more fuel to accelerate, which has more weight in turn. The relationship grows exponentially. To reach even a small fraction of the speed of light with chemical propulsion would require a fuel supply larger than the entire mass of the observable universe. It is not a difficult problem to be solved with better engineering or cleverer design. It is an impossible one, closed off by an arithmetic that no amount of ingenuity has ever managed to argue with. The 149th fact is that this is why every serious proposal for interstellar travel begins by abandoning the rocket entirely, or at least by abandoning the fuel. Either the energy must come from somewhere other than the ship, or the propellant must be something other than chemistry. Nuclear options have been sketched. Antimatter has been considered. Beams of light from home have been proposed. What all of them share is a recognition that the ordinary approach cannot work at any scale. Getting to the nearest star requires not a better rocket, but a different idea entirely. The 150th fact is that one of the earliest and most serious such ideas was a British study from the 1970s called Project Daedalus. It proposed an enormous unmanned probe driven by tiny pellets of fusion fuel detonated behind it at a rate of 250 per second, pushing the craft to something like 12% of the speed of light. The vessel would have weighed 50,000 tons, most of it fuel, and would have needed to mine helium from the atmosphere of Jupiter. It was never built, but it proved that the problem could at least be written down. The 151st fact is that an even older idea from the 1950s was called Project Orion, and it was startling in its directness. The plan was to propel a spacecraft by detonating nuclear bombs behind it, one after another, and absorbing each blast with an enormous shock-absorbing plate. It sounds absurd, and yet the physics is sound and the engineering was taken very seriously indeed by capable people. It was abandoned for reasons that had as much to do with treaties as with technology. Some ideas are set aside not because they fail, but because of what they would require. The 152nd fact is that another approach, gentler and stranger, is the idea of a generation ship, a vessel that never goes fast at all. Instead, it carries a whole community outward on a journey of many centuries, with children born and lives lived and generations passing entirely aboard. Those who arrive would be the distant descendants of those who left, and would know the Earth only as a story. It is less an engineering problem than a human one. Whether such a thing could hold together across 300 years is a question no one can answer, and perhaps no one should have to. The 153rd fact is that even the very simplest interstellar mission faces a difficulty that has nothing to do with propulsion, and that is simply lasting long enough. Nothing we build survives for tens of thousands of years. Metals grow brittle. Electronics degrade. The steady rain of cosmic rays gradually rewrites the memory of any computer. A machine sent to Proxima Centauri would need to endure a span of time longer than the pyramids have stood, unattended, in vacuum. Building the engine is only half the problem, and quite possibly the easier half. Everything we know about making things last is drawn from experience measured in decades, and this would ask for something measured in ages. Building something that still works when it arrives is the other half. The 154th fact is that there is also the question of stopping, which is very much harder than starting. A craft accelerated to a great speed will arrive at Proxima Centauri at that same great speed, and will pass straight through the system in a matter of hours before hurtling onward into the dark forever. Slowing down requires as much energy as speeding up did, and there is no fuel station waiting at the far end. Most proposals accept this and plan for a flyby, A single brief glance after a journey of decades and then nothing more. The 155th fact is that the total energy required to send even a modest payload to another star is difficult to overstate. To push a single ton of material to a tenth of the speed of light requires roughly the entire annual electricity production of a large country, delivered perfectly with no waste. This is not a matter of clever engineering. It is a bare requirement of physics, unavoidable and non-negotiable. Interstellar travel is not held back by a lack of imagination. It is held back by the sheer, unyielding size of the energy bill. The 156th fact is that despite all of this, 5 human-made objects are currently on their way out of the solar system and into interstellar space. Voyager 1 and Voyager 2, Pioneer 10 and Pioneer 11, and the New Horizons probe that photographed Pluto. 2 of them have gone quiet, their power sources long exhausted. The others will fall silent within a decade or two. But all 5 will continue coasting outward for billions of years, long after everything that made them has vanished. 5 small quiet things, adrift among the stars. The 157th fact is that those spacecraft will very likely outlast the Earth itself. Nothing out there will erode them. There is no weather in interstellar space, no oxygen to corrode metal, almost nothing at all to strike them. A Voyager probe drifting through the galaxy in a billion years will look very much as it does tonight, with its golden record still attached, its antenna still pointed at a planet long since changed beyond recognition. They are the most durable things our species has ever made, and not because we built them especially well. Every monument on Earth is being worn quietly away by wind and water even now, while those 5 probes are touched by nothing at all. Simply because we sent them somewhere nothing happens. The 158th fact is that this is the reason attention has turned so strongly towards sending something very small rather than something very large. The energy required scales directly with mass, and so a probe weighing a few grams rather than a few tons brings the whole problem down by a factor of 1,000,000. You cannot send a person that way, or an engine, or a fuel tank. But you might send a camera and a radio and a sail. The way through the wall is not to push harder, but to carry very much less. The 159th fact is that there is a certain quiet dignity in how honestly this problem has been faced by the people who study it. No one pretends the difficulty away. The papers are full of hard numbers and unflattering conclusions, and the authors publish them anyway. It is one of the few fields where the greatest minds spend their careers carefully documenting exactly how far out of reach the goal remains. And yet they keep working at it, which is, in its own way, one of the more admirable things our species does. The 160th fact is that for tonight, at least, the difficulty need not trouble you in the slightest. No one is going anywhere, and nothing is required of anybody. The nearest star will remain exactly where it is, 4¼ light years off, entirely indifferent to whether we ever manage to reach it. The problem will still be there in the morning, and in 100 years, and it will wait as patiently as the star does. Let it wait. There is nothing to solve now, only breathing and stillness, and the soft dark all around you. The 161st fact is that in April of 2016, a small group of physicists and engineers announced a project with the aim of reaching Proxima Centauri within a single human lifetime. They called it Breakthrough Starshot, and their proposal was to abandon rockets entirely and push a fleet of extremely small spacecraft using nothing but light. It was announced only 4 months before the discovery of Proxima b, which meant that within a single year the idea acquired both a method and a destination. 2 pieces of news arriving almost together, and suddenly the nearest star had a plan attached to it. The 162nd fact is that the central idea of Starshot rests on the simple fact that light exerts pressure, however faint. A photon carries no mass, but it does carry momentum, and when it strikes a reflective surface, it gives that surface a tiny push. On Earth, the effect is far too small to notice, drowned out by everything else. But in the vacuum of space, with nothing to resist it, a continuous push, however gentle, can build enormous speed over time. Sunlight has been used to steer spacecraft already. Light can move things very slightly and very persistently. The 163rd fact is that the vessel in this plan is called a light sail, and it would be almost unimaginably thin and light. The concept calls for a sail a few meters across, weighing perhaps a single gram, made of a reflective material only a few hundred atoms thick. It would be less substantial than a soap bubble and far more delicate than tissue paper. Attached to it would be a chip the size of a postage stamp, carrying cameras and sensors and a tiny communications laser. The whole spacecraft would weigh less than a paperclip. The 164th fact is that the push would come not from the sun but from an enormous array of lasers built on the ground here on Earth. The proposal calls for perhaps 100 million individual laser units spread across a square kilometer of desert, all firing together and combining into a single beam of roughly 100 gigawatts. That is comparable to the entire electrical output of a large country, focused into one beam, aimed at something the weight of a paperclip, for a period of about 10 minutes. The 165th fact is that in those 10 minutes, the sail would accelerate to about 20% of the speed of light. That comes to roughly 60,000 kilometers every second, which is more than 3,000 times faster than Voyager 1 has ever traveled. It would cross the orbit of Mars within an hour of launch. It would pass Pluto in a matter of days. Everything humanity has ever sent into space would be left behind almost immediately, and every record of speed we have ever set would be broken within the first minute of the burn, and then it would coast silently for the following 20 years. The 166th fact is that the acceleration involved would be violent beyond anything a living thing could endure, which is precisely why the craft must be so small. A sail pushed from rest to a fifth of light speed in 10 minutes experiences something like 60,000 times the force of Earth's gravity. No human being, no animal, no conventional machine could survive that for an instant. But a solid chip of silicon has no organs to crush and no structure to buckle. Smallness is not merely convenient here. It is the only thing that makes the whole scheme possible. The 167th fact is that at 20% of the speed of light, the journey to Proxima Centauri would take about 20 years. A person who helped launch such a craft in their 30s could plausibly still be alive when it arrived. That single sentence is what makes the project remarkable, and it is why it captured so much attention. For the first time, someone had sketched a route to another star that fit inside a human life rather than inside a civilization. 20 years of coasting and then arrival. The 168th fact is that the journey would not end with arrival, however, because the signal must still come home. Even after the craft reached Proxima Centauri and gathered whatever images it could, the data would have to be beamed back across 4¼ light years, traveling at the speed of light. So the pictures would be more than 4 years old before anyone on Earth saw them. 20 years of waiting, and then for more. A total of nearly a quarter of a century between the launch and the first photograph. The 169th fact is that the encounter itself would be extraordinarily brief, and this is one of the melancholy details of the plan. Traveling at 20% of light speed, the probe would cross the entire Proxima Centauri system in a matter of hours. There would be no orbit, no lingering, no second look. It would sweep past its target, take whatever it could as fast as it could, and hurtle onward into the dark forever. 2 decades of travel for a few hours of observation. Everything the mission was built to do would happen in less time than a single night's sleep, after 20 years in which nothing at all happened. and then an endless departure. The 170th fact is that the plan calls for sending not one probe but a great swarm of them, perhaps 1,000 or more, launched one after another. Some would fail. Some would be struck by dust. Some would miss. But if even a handful survived and returned data, the mission would succeed. It is a philosophy quite unlike the way we build spacecraft today, where a single enormously expensive vessel must work perfectly. Here the answer to fragility is simply numbers. Send 1,000 paperclips and hope that a dozen make it. The 171st fact is that one of the gravest dangers along the way is dust, which sounds harmless until you consider the speed. A single grain of interstellar dust, no larger than a particle of smoke, striking a sail at 60,000 kilometers per second would release energy comparable to a small explosion. Over 4 light-years of travel, some collisions are essentially guaranteed. Engineers have proposed edge-on orientation and protective coatings and clever materials. But the honest answer is that speed turns emptiness into hazard. And the emptier the road, the faster you dare to go. The 172nd fact is that another serious problem is the simple matter of aiming. And it is harder than it sounds. Proxima Centauri is moving, and the Earth is moving, and the light from the star is 4 years old, so the target must be led like a bird in flight. A tiny error in the initial direction, magnified across 40 trillion kilometers, would cause the probe to sail past at a distance of many billions of kilometers and see nothing at all. The precision required is roughly like hitting a coin from across a continent. The 173rd fact is that the returning signal presents a difficulty that many people find the most surprising of all. The probe carries a laser weighing a fraction of a gram, powered by a source no larger than a fingernail, and it must send an image across 4¼ light-years to be caught by a receiver on Earth. The signal arriving would be almost inconceivably faint, a scattering of individual photons spread over hours. Detecting it would require the same enormous laser array to serve in reverse as a listening dish, gathering photons one at a time and patiently assembling them into a picture over the course of many days. A beam becoming an ear. The 174th fact is that despite all of this, no part of the Starshot proposal violates any law of physics, and that distinction matters a great deal. Everything it requires already exists in some form. Lasers exist. Reflective films exist. Miniature cameras and radios exist. What does not exist is any of it at the required scale, or at anything close to the required cost. It is an engineering problem of staggering size, but it is only an engineering problem, which is a very different thing from an impossibility. The 175th fact is that the estimated cost of the full system runs into the many billions, comparable to the largest scientific instruments ever constructed. And yet the same is true of every great telescope, every particle accelerator, every space station. Such things are built when enough people decide, over enough decades, that they are worth building. The founders of Starshot were careful to describe it as a project spanning generations, with the first launch perhaps 30 or more years away. Nobody involved expects to finish it quickly, and nobody involved seems especially troubled by that. The 176th fact is that even a successful mission would return only a handful of images, and they would not be the sweeping vistas people imagine. A camera the size of a fingernail, traveling past a dim red star at 1/5 of the speed of light, would capture a few frames of a small crescent world and a faint red sun. They would be blurry, they would be brief, and they would be the first photographs ever taken of a planet orbiting another star, from close range, taken by something that we had built and sent and then waited upon for 1/4 of a century, which would make them, without argument, the most extraordinary pictures in human history. The 177th fact is that other approaches have been proposed alongside the laser sail, and one of the most elegant is the solar sail driven purely by our own sun. A large enough sail passing very close to the sun could ride the pressure of ordinary sunlight outward, gaining speed without any beam or any infrastructure at all. The achievable speeds are lower, perhaps a few percent of light speed at best, which would stretch the journey to centuries. But it needs no 100-gigawatt laser and no square kilometer of desert, only sunlight and patience. The 178th fact is that there is a deeper question underneath all of these plans, which is whether we would send machines or something more. Every serious proposal for the coming century involves probes, not people, because the physics is so much kinder to a payload weighing a gram. Human beings are heavy and fragile, and require air and water and food and company for 20 years. If anything of ours ever reaches Proxima Centauri, it will very likely be a small silent ship, carrying our curiosity, but not our bodies. The 179th fact is that whatever we eventually send, the first message will travel outward long before any vehicle does. Radio signals from Earth have already been drifting into space for roughly a century, and they passed Proxima Centauri long ago, though far too faint by then for anything to notice. Whatever the future holds, our light has been there for decades already. In the smallest possible sense, we have already arrived. Every broadcast, every signal, every stray transmission has been streaming outward without pause since long before anyone thought to aim one deliberately. Not with a ship, but with a whisper, and it went at the speed of light without any effort at all. The 180th fact is that there is something quietly moving about a species that cannot leave its own neighborhood, yet spends its evenings carefully working out how it might. We are not going to Proxima Centauri tonight, nor this century, and quite possibly not ever. And still the calculations are made, the papers written, the sails imagined. It is a kind of hopefulness that costs nothing and asks nothing. Let that thought settle gently as you drift. The long, patient reaching of a small world toward a small red light, 4¼ years away. The 181st fact is that if you were standing tonight on a world circling Proxima Centauri, and you looked up into that unmoving sky, you would be able to see our sun with your own eyes. It would not be a sun there, of course, only a star among stars. But it would be a bright one, shining at about magnitude 0.5, comfortably among the 24 brightest points in the whole of that sky. Our sun would be, to them, an ordinary bright star, noticeable, unremarkable, and entirely anonymous. The 182nd fact is that from Proxima Centauri, our sun would appear in the direction of the constellation we call Cassiopeia. That is the familiar zigzag of 5 stars, shaped like a great W, that circles the northern pole of our own sky and never sets for much of the northern world. An observer at Proxima looking toward that pattern would see it slightly rearranged by the change of perspective, and they would see one extra star added to it, a yellow point that does not belong there. And that extra star would be us. The 183rd fact is that the addition of our sun would turn the familiar W of Cassiopeia into something more like a zigzag with an extra bend, a shape that no one on Earth has ever seen. Constellations are not real groupings at all, only chance alignments from one particular vantage point, and they dissolve and reform the moment you move. Travel 4¼ light years and every pattern in the sky shifts a little. Nearly all the same stars would be there, in very nearly the same places, since 4 light years is far too small a shift to disturb anything genuinely distant, arranged into figures that no human eye has ever recognized. The 184th fact is that the light of our sun reaching Proxima Centauri tonight left the Earth's neighborhood more than 4 years ago. Exactly as their light left theirs, the exchange is perfectly symmetrical. If anyone there were looking toward Cassiopeia at this moment, they would be seeing our sun as it was 4 years and 3 months back, which is a version of it very slightly different from the one that rose over you this morning. 2 stars, quietly looking at each other's past, and neither one aware of it. The 185th fact is that the Earth itself would be entirely invisible from Proxima Centauri to any ordinary observation. Our world shines only by reflected sunlight, and at that distance it would be lost in the glare of the sun beside it, a mode of light a billion times fainter, buried in the brightness of its own star. Only an instrument far better than anything we possess could pick it out. The whole of human history, every city and voice and song, sits inside a point of light that cannot be seen from the nearest neighbor's window. The 186th fact is that the night sky from a world at Proxima Centauri would hold one sight we have never known, which is the pair of Alpha Centauri A and B blazing together. They would appear as two dazzling stars close beside one another, far brighter than anything in our sky, bright enough to cast shadows on the ground and to read a page by. And they would remain in the sky through the long, unmoving night, never rising, never setting. Two brilliant lanterns, fixed in place forever, lighting a darkness that never ends. The 187th fact is that most of the rest of that sky would look reassuringly familiar to us. Orion would still be Orion. The Southern Cross would still hang in its place. The Milky Way would still stretch across the whole heaven in the same soft luminous band. 4¼ light-years is an enormous distance to us, and it is essentially nothing at all to the galaxy. Move that far and the universe barely notices. The sky of the nearest star is our own sky, very slightly rearranged. Only the handful of stars closest to us would appear noticeably shifted, and everything beyond a few dozen light-years would sit exactly where we have always seen it, and otherwise entirely unchanged. The 188th fact is that this sameness is itself one of the loveliest facts in all of astronomy, and it is worth resting on for a moment. Whatever lies out there, however strange the worlds, it looks up at the same stars we do, the same Orion, the same great river of the Milky Way, the same distant galaxies smudged faintly across the dark. We share a sky with every world for a very long way in every direction, which is a kind of company even across an emptiness no one can cross. The 189th fact is that the silence between the stars is the deepest silence that exists anywhere. There is no air out there to carry a sound, and so there is nothing to hear, not a whisper, not a stir. If the greatest flare Proxima Centauri has ever produced happened directly beside you, you would hear absolutely nothing at all. The whole enormous machinery of the galaxy turns without a single sound. It is not a frightening silence at all, and there is nothing in it that could ever startle anyone. It is simply the quietest room there has ever been, and it has been quiet for a very long time, and it stretches out in every direction, forever. The 190th fact is that the space between us and Proxima Centauri is also very close to absolute cold, hovering only a few degrees above the lowest temperature the universe permits. Nothing warms it but the faint afterglow of the beginning of everything, spread evenly across the whole sky at about 3 degrees above absolute zero. That gentle warmth is the oldest light there is, and it fills all of space, and it is falling on you now unnoticed, along with everything else. The dark between the stars is not empty. It is simply very, very quiet and very old. The 191st fact is that Proxima Centauri will still be shining, exactly as it does tonight in 100 billion years. By then our own sun will have swelled into a red giant, swallowed the inner planets, shed its outer layers into a glowing shell, and collapsed into a white dwarf slowly fading toward black. Every bright star you can name will have run its course, and the small red ember 4 light-years away will not have changed in any way that could be measured. It will be the same brightness, the same deep red color, the same temperature, holding the same small planets in the same short and hurried orbits, still burning gently, still barely begun. The 192nd fact is that in the far future, when our sun has died and the galaxy has grown dim, Proxima Centauri may well outlive not only our star but the very idea of a bright sky. A universe lit by red dwarfs alone would be dark by our standards, and calm, and almost impossibly long-lasting. Every ending we know is the ending of something fast. The slow things do not end. They simply persist, quietly, past every event that seems important, which is perhaps the gentlest fact astronomy has to offer. The 193rd fact is that in about 26,000 years, Proxima Centauri will make its closest approach to our sun, drawing in to roughly 3 light-years before beginning its long retreat. Nobody alive will see it, and nobody's descendants will notice, since the difference would be invisible without instruments. But it will happen on schedule without anyone attending. The stars keep their appointments whether or not we are there to mark them. And that thought has always struck me as more comforting than sad. The 194th fact is that everything we have learned about this small red star was gathered from light, and nothing else. No one has ever touched it, or sampled it, or sent anything even 1,000th of the way toward it. Its mass, its temperature, its planets, its flares, its age, its motion, all of it came from patiently collecting photons that had traveled 4¼ years to reach a mirror on a mountaintop. That is the whole of our contact with the nearest star, and it has been enough to fill entire libraries. Light is a remarkably generous messenger, carrying nearly everything about its source to anyone patient enough to catch it. A faint red light, and a great deal of care. The 195th fact is that we have traveled a long way together tonight, from a faint red on a glass plate in Johannesburg to a world of eternal twilight, from 40 trillion kilometers of emptiness to a sail the weight of a paperclip riding a beam of light, and running through all of it is a single small star that has never once known we were watching. Every piece of it was found by someone patient enough to keep looking a little longer. There was no danger anywhere in any of it, only distance, and distance asks nothing whatever of anybody. Nothing out there has ever needed our attention, and nothing out there has ever threatened us in the slightest. And distance is a very gentle thing. The 196th fact is that the nearest star to your home tonight is close enough to have a name and far enough to be forever out of reach. And both of those things are true at once. It is our neighbor and it is unreachable. It is next door and it is 4¼ years away at the speed of light. There is no contradiction in it, only scale. The universe holds both nearness and vastness in the same small red point, and it holds them without any difficulty at all. The 197th fact is that perhaps the quietest gift of Proxima Centauri is the way it makes distance feel like something restful rather than something lost. Nothing out there is waiting on us. No message needs answering, no journey needs planning, no problem needs solving tonight or in any of the nights to come. The nearest star has been burning peacefully for 5 billion years without any help from anyone, and it will go on doing so. To rest inside that thought is to be relieved of a great deal, and to be reminded that stillness is allowed. The 198th fact is that there is nothing at all being asked of you now. Nothing to carry, nothing to finish, nowhere you need to be. The little red star will keep its small fire whether you are awake or asleep, and it will keep it just as faithfully through every hour of your rest. Let your shoulders soften into the bed beneath you. Let your hands grow heavy and warm. Let the day loosen its grip and slide quietly away from you into the dark. There is only breathing left to do now, and even that will manage itself. The 199th fact is that as your thoughts grow soft and slow, you might imagine yourself lifting gently away from the roof above you, up past the clouds and the cold, clear air, out beyond the quiet planets and into the long dark between the suns, There is no cold out there that can reach you, no sound, no hurry, no weight of any kind. Only the slow drift of 40 trillion kilometers of perfect stillness, and far ahead, growing very slowly warmer, a small red light waiting patiently at the end of it, and no reason at all to arrive. The 200th fact is that long after this night has passed, and long after all our nights have passed, Proxima Centauri will still be burning quietly 4¼ light-years away, the nearest of all the stars, keeping its small red fire above a sleeping world, exactly as it does above you now. So let your thoughts grow quiet, and let the last of the day dissolve into the dark, and drift gently outward toward that small patient light, into the calm and endless night. Rest now, sleep well, and thank you for drifting with me beyond the stars.